Hello children. In our last class, we discussed about the preferential discharge of ions, the three factors affecting the preferential discharge of ions. We said that there are three factors, and which are the three factors? The position in the electrochemical series, position of the ion in the electrochemical series, the concentration of ions in the electrolyte, and the nature of the anode. So if the nature of the anode, we'll start from the anode, the third factor. So if the nature of the anode is active, then the first two will not play a role. Only the anode will take part in the reaction. If the anode is not active, it is passive, then only the first two will play a role. And the second one is concentration of the ions. And if there is nothing mentioned about the concentration, whether it is dilute or it is concentrated, nothing is mentioned, then we don't even go to the second factor, we directly come to the first factor. And what is the first factor? The relative position of the ions in the electrochemical series. We already did one example of electrolysis, that is last time we did electrolysis of molten lead bromide, and we saw that what is the electrolyte we took? Molten lead bromide. What was the electrolytic cell? It was made up of silica, yes. Why? Because silica is inert to this, it can withstand high temperature and inert to bromine vapors. And the electrodes chosen is of graphite, because graphite is inert to bromine vapors, which is liberated at the anode. Okay. Today we go on to our second example, and in this example you will see there is preferential discharge. In the first one, that is molten lead bromide, there was no need of any factors. We didn't have to consider the factors or think which ion will get discharged, because there was only one ion at the cathode and one ion went to the anode. But now, today we will do our second example. Let us start with, let me write examples of electrolysis. Okay, so examples we are doing. Let us go to our second example today. And what is the second example? Electrolysis of acidified, acidulated, let us write, water. That means water, and we all know, you know, that water is a bad conductor of electricity. So what do? To initiate the process of ionization, we need to put a few drops of acid into it, and here we put a few drops of concentrated sulfuric acid. So in our electrolyte now, what all we have? We have water and we have the acid molecules. Two things are there. Now both will ionize. Let us see how they ionize. Water will ionize always as H plus and OH minus. H2SO4 will always ionize as H plus. There are two H's here, H2, that's why 2H plus SO4, 2 minus. Okay, because sulfate's valency is 2, so 2 minus. Hydrogen's valency is only 1, so 1 plus. Okay, so this is how the dissociation or ionization, in this example it is ionization because both are, you can see water is a covalent compound. So ionization takes place. Now what? At the cathode. Who will go to the cathode? Cathode is negatively charged electrode. So the opposite charge ions will be attracted towards the cathode. So which is the ion present? In both the cases it is H plus. So which ion will go to the cathode? Only one is there, H plus, so no selective discharge here. At the anode, who will go? At anode, there are two negative ions. See, two negative ions, OH minus and SO4 2 minus. OH minus and SO4 2 minus. Now, let us see how it's getting discharged. H plus will take up one electron and become H. H plus H will become H2. Okay, that means in the first step only one atom of hydrogen is being produced, and after that it has to wait for another atom of hydrogen to be produced. Then the two atoms of hydrogen will combine to give hydrogen molecule and colorless odorless gas, which burns with a pop sound, is liberated at the cathode. Okay. Anode, what will happen? There are two ions going to the anode, but which one will get discharged? Now you have to go to the acidulated water. We are using platinum electrodes. Okay, platinum electrodes, and we know platinum is an inactive electrode. Platinum is an inactive electrode. So platinum electrodes. So at the anode, the third factor of selective discharge, third factor is the nature of the anode. So nature of the anode is passive, not active, inert. So we are doing away with the third factor. Concentration, nothing is told about concentration, so we will do away with the concentration. And the third one is the relative position in the electrochemical series, and that we have to see out of these two which is below in the electrochemical series. OH minus is below. So OH minus will get discharged, and sulfate ion is the spectator ion. Spectator means spectator ion. What do we call it? Spectator ion, sulfate ion. Why? Because sulfate ion went, it migrated towards the anode, but it did not get discharged. Who got discharged? OH minus got discharged in preference to sulfate because of the position in the electrochemical series. So OH minus will get discharged. Let us see how. OH minus has one negative charge, will give up that one electron and become OH. Okay, so in one step this has happened. Now 4 such OHs will join together. 4, okay? 4 OH will join together to give what? 2 molecules of water. 2 molecules of water and 1 molecule of oxygen. And 1 molecule of oxygen. Water, you know, is a liquid. It will get back to the electrolyte. One gas is being liberated, oxygen, and how will you tell the observation? Colorless, odorless gas which rekindles a glowing splinter is liberated at the anode. Okay, at the cathode what is liberated? A colorless, odorless gas which burns with a pop sound is liberated. At the anode, oxygen is liberated, colorless, odorless gas which rekindles a glowing splinter. Now another thing to note here, children, is that in the time when 4 OHs combine, that means 4 such reactions has to occur. 1, then 2, 3, 4. 4 such reactions will occur, then only we will get 4 OH. 4 OH will join together to give 1 molecule of water. 4 OH, 4-step reaction it is. Then it will give 1 molecule of oxygen. And what about here? 2 steps. It has to it has to undergo 2 steps to give 1 molecule of hydrogen. That means when 1 molecule of oxygen is being liberated here, how many molecules of hydrogen will be liberated? 2 molecules. Why? Because after 4 steps you got 1 molecule of oxygen. And here after 2 steps we got 1 molecule of hydrogen. That means at the time when 1 molecule of oxygen oxygen is produced here, here there will be 2 molecules of hydrogen produced. So the volume of hydrogen produced will always be double that of the volume of oxygen produced. At the same time, we are talking about at the same time. Okay. So this thing is to be noted, and that is why we say that during the decomposition of water, the volume of hydrogen to oxygen by volume, yes, by volume is 2:, the ratio of hydrogen to oxygen by volume is how much? 2:1, by 2:1, because at this time the hydrogen will produce 2 molecules of hydrogen. Okay, so this is electrolysis of acidulated water. Okay, very easy. First you must write the dissociation or the ionization reactions, then the cathode reaction, anode reaction. What is a spectator ion? Spectator ion is an ion which migrated to the anode or the cathode, any of the electrode, migrated but does not get discharged. So that is spectator ion. And here who is the spectator ion? Sulfate ion is the spectator ion. Okay. So this is electrolysis of acidulated water. Let us come to our third one. Okay, third one is also. This is not in our syllabus, children, but still I am telling you this for you to understand the next one. That is electrolysis of acidified copper sulfate solution. Acidified copper sulfate solution. Now how many things are there in acidified copper sulfate solution? 3 compounds are there. 3 different substances are there. Water, copper sulfate and acid. Water, acid and copper sulfate. Okay. And how will copper sulfate dissociate? Cu2 plus SO4 2 minus. Okay, Cu2 plus and SO4 2 minus. Okay. Now what will happen? Let us see at the cathode. Who all will go to the cathode? H plus and Cu2 plus. H plus and Cu2 plus will go to the cathode at the anode. At the anode, who all will go? This is OH minus. Okay. So OH minus and sulfate will go. OH minus and sulfate 2 minus. Now let us see. 2 are going. Surely the factors of selective discharge have to be taken into consideration. Let us see what is happening. Cathode. At the cathode, H plus and Cu2 plus is going, and which is down in the electrochemical series relative position if you consider Cu2 plus is below. Yes, we are doing away, it is platinum electrode, so the electrode won't play a role because it is inert. The concentration is not playing a role here, and now we have only relative position of the ions in the electrochemical series. So H plus and Cu2 plus. Cu2 plus will get discharged. How will it get discharged? Cu2 plus will take up 2 electrons and become Cu. And Cu is what? Reddish brown metal. And children, you please learn this color only. For copper, keep in mind that it is reddish brown. Don't write red. Don't write pink. only write reddish brown copper is deposited at the cathode. Reddish brown copper metal is deposited at the cathode. At the anode, what happens? OH minus and sulfate ion is there, which is having a lower position in the EC series, OH minus. So, OH minus will give up one electron, give away, become OH, and 4 OHs will combine together to form 2 molecules of water and 1 molecule of oxygen. So, what are your observations at the 2 electrodes? At the cathode, reddish brown metal is deposited, and at the anode, a colorless odorless gas is liberated which rekindles a glowing splinter. Observations are important, children. And what else can come from this part? The electrode reactions can come. But when you write the electrode reactions, this is the cathode reaction, this is the anode reaction, it is always better to write the ionization reactions also. It's always good to write, though there is no marks for this. You will get 1 mark for the cathode reaction, 1 mark for the anode reaction, no marks for this, but so that you don't go wrong, that is why better to write the ionization reactions as well. Okay, so this is what you see in a when acidified copper sulfate solution is electrolyzed using platinum electrodes. Another very important thing, this is not in our syllabus, I told you children, but still I am telling you so that you understand our next example better. So acidified copper sulfate solution, what color it is? Copper sulfate. Last year also you have done the heating experiment of copper sulfate, blue vitriol, and this year also we will be doing it in the practical. So what is the color of copper sulfate solution? Blue. Yes. So the copper sulfate which we took as an electrolyte in the beginning, the full electrolyte is blue in color. Okay. We see that as this reaction proceeds, the anode and the cathode reactions proceed, then we see that the color of the electrolyte, the blue color of the electrolyte keeps fading. It keeps fading. Why does the color fade here? Why does the color fade? The color fades because the blue color of the electrolyte is due to what? Cu2 plus ion. The blue color of the electrolyte is due to which ion? Cu2 plus ion. Okay? In the ionic state. So this Cu2 plus ion takes up 2 electrons and becomes metallic copper. It becomes metallic copper. That means what is happening? The ion Cu2 plus ion number is reducing in the electrolyte. As the reaction proceeds, what happens? The concentration of Cu2 plus ions in the solution, in the electrolyte, goes on decreasing, and because of that the color of the electrolyte keeps fading. Okay, so first you will write that the color of copper sulfate solution is blue because of presence of Cu2 plus ions. As the reaction proceeds, as the electrolysis proceeds, what will happen? The concentration of the Cu2 plus ions will go on decreasing in the electrolyte, and thus the color will also go on fading. Okay, so the color will fade, the electrolyte's color will fade. Remember that. Okay, so that is about acidified copper sulfate solution. Now we come to acidified copper sulfate solution using copper electrodes. When we use copper electrodes, this ionization reaction is same. The ions migrating towards the 2 electrodes is also same. The cathode reaction will also be same because out of the 2, copper will get discharged because of the relative position in the electrochemical series. But here at the anode there will be a difference. Now what is the change that we see here? We see that two ions migrate towards the anode, but none of these two will get, both will become spectator ions. And here, which is the spectator ion? Hydrogen, H plus is the spectator ion. And here OH minus and SO4 2 minus both are spectator ions. Why? None of this will get discharged because copper electrode is being used, copper anode is being used, and copper anode being used means it is an active anode. Active anode means the anode will take part in the reaction and none of the ions migrating towards it will get discharged. So, now what will happen? Anode will take part in the reaction means what? From the electrode copper electrode, the atom of copper Cu in the atomic state will lose 2 electrons, will give up 2 electrons and become what? Cu2 plus. Okay? So, what happens here? One by one the atom will come out from the electrode, from the anode. So, what do you think will happen to the mass and the size of the anode? Slowly the mass and the size will go on decreasing. As the reaction proceeds, the mass of the anode will go on decreasing. So that is what is happening here. Okay, so Cu minus 2 electrons will give Cu2 plus. So we see here that at the cathode, one Cu2 plus is getting discharged and becoming copper. This copper is depositing on the cathode as reddish brown metal. So that means the cathode is going on becoming heavier and heavier. Yes? Because metal is depositing on it. Okay, that is observation. So cathode, what is happening? Reddish brown metal is being, that is our first observation. Reddish brown metal is being deposited. And what is our second observation? That the mass of the cathode will go on increasing. So here at the cathode we see that Cu2 plus is becoming copper, and at the anode the opposite reaction is happening. Cu is becoming Cu2 plus, and then this Cu2 plus will get into the electrolyte. So one Cu2 plus has gone away from the electrolyte into the cathode. The other Cu2 plus from the anode has come into the electrolyte. Okay, so what happens? So the concentration of Cu2 plus ions in the solution in the electrolyte, the concentration of Cu2 plus ion remains constant. The number of Cu2 plus ions in the electrolyte remains constant. Why? Because for every copper ion discharged at the cathode, one copper ion is being produced at the anode. Okay? So the number of Cu2 plus ions in the electrolyte remains constant, and if the Cu2 plus ions remain constant, then what will happen to the color of the electrolyte? The color of the electrolyte will also remain intact. There will be no fading. There will be no fading. Okay? When we use platinum electrodes, the copper sulfate solution's blue color will keep fading. But when you use copper electrode, then the blue color will not fade. It will remain as it was in the beginning. Why? Because for every copper ion discharged at the cathode, one copper ion is being produced at the anode, which will get into the electrolyte. Okay? So these were few of our examples of electrolysis in our syllabus, children. So you must be very well acquainted with lead bromide, molten lead bromide, acidulated water, and copper sulfate solution using copper electrodes. This one, copper electrodes. Okay? So this is the fourth one that we did today, but the third one which we did, that copper sulfate solution using platinum electrodes, is not in our syllabus. But only you must remember that when we use platinum electrodes, the color of the electrolyte will keep fading. Okay? So for every electrolysis example, you must know what is the observation at the cathode, what is the observation at the anode, and the electrode reactions, both. That is it. So That's all for today, children. The next part we will do it in the next class.